Jupiter is not what you think. And here's the truly eerie part. The clearer we see it, the more unsettling it becomes, because this planet is starting to defy the textbooks and even our best scientific models. The Great Red Spot, the most famous storm in the solar system, is shrinking. Yet, at the same time, there are signs it may be rising higher, pushing beyond what we thought was physically manageable. At the poles, the superstorms don't drift around in chaos. They lock into formation, arranged like a polygonal wreath, as if an invisible hand is holding them in place. And deeper still, beneath a cloud deck only tens of kilometers thick, Jupiter may be a world of liquid hydrogen and metallic liquid hydrogen, a vast, electrically conducting ocean running like a planetary generator. From images that are too beautiful to be real, to data that is genuinely terrifying. Why are Jupiter's storms not shallow at all, but plunging hundreds of kilometers down? How can a tiny moon pump fuel into Jupiter's colossal magnetic field? And finally, why might Jupiter's core be layered and not even solid the way we were taught? A long time ago, Jupiter in books looked like a blurry brown-red smear, a few colored bands and a red dot, but now it's a living canvas. Deep blues, icy whites, pale pinks, stormy grays, colors in constant motion. And the most important thing is this: none of it is CGI. Many of these images come from JunoCam, a camera originally mounted on NASA's Juno spacecraft, mainly to document the mission. But then something remarkable happened. NASA released the raw data, and thousands of people worldwide, artists, programmers, scientists, photographers, downloaded it, processed it, color-corrected it, pulled out detail, turning scientific imagery into true planetary art. But the beauty is only the surface. The real question is, what are these images revealing about Jupiter's true nature? Juno has been orbiting Jupiter since 2016 on an elongated ellipse, sometimes far away, sometimes breathtakingly close, like a near collision. With every close pass, resolution spikes, lighting angles change, shadows sharpen. The atmosphere suddenly looks three-dimensional. There are moments when sunlight skims across the cloud tops like an Earth-like sunset, except there is no rain, no water. What falls there may be ammonia rain and dirty ice particles mixed with chemicals, and this is Jupiter's trap. The closer you zoom in, the less it looks like a still planet. You start seeing strange, bright spots that appear, then vanish. New storms are forming in just days, atmospheric grooves that look like fresh scratches across the surface. And then you notice cloud shadows. One critical clue: Jupiter's atmosphere isn't a flat layer, it's stacked, multi-tiered structure deep. Jupiter is no longer a colored marble. It feels like a living weather machine, breathing, reshaping, reacting, self-adjusting. So if what we see is only a cloud layer tens of kilometers thick, what is controlling everything from below? Now we have to talk about the Great Red Spot. If you still think it's just a red dot, the latest close-up images destroy that idea. Up close, it's a multi-layered system. Storms within storms. Cloud bands twisted and pulled like taffy. Smaller vortices dragged into the edges, shredded and erased, as if you're staring into a colossal eye, blinking in slow motion, and every blink swallows a smaller storm whole. But here's the more disturbing part. The Great Red Spot is shrinking in width, and instead of weakening in the logical way, the data suggests it may be rising in height. Like a storm standing up into something taller, more structured, more extreme. Science fears this kind of behavior because energy doesn't disappear, it only changes form. Maybe the Great Red Spot is pushing energy deeper. Maybe it's drawing power from a different atmospheric layer. Maybe it's reorganizing convection inside Jupiter in a way older models simply cannot capture. And that triggers a cascade of questions. If a storm can stand up, what is it anchored to underneath? Which layer is it tied to? Where is the energy coming from? Now shift your gaze to Jupiter's North Pole, where the planet becomes almost unrecognizable. The familiar horizontal bands vanish. Instead, you see a formation of giant storms arranged in a polygon around a central vortex, 6, 7, sometimes 8 storm petals, holding formation for years. The unsettling part isn't just the size, it's the coordination. These are massive cyclones, yet the spacing between them stays nearly perfect, like they're caught in a physical locking mechanism, close enough to interact, but not so close they destroy each other. Strong enough to survive, yet somehow constrained into a stable pattern. No other planet in the solar system displays anything like it. And just when you think that's the peak of the story, a side character steps in and steals the entire scene. Io, a small moon, about the size of Earth's moon. But unlike our moon, Io is not dead. Io is a living geological hell, hundreds of volcanoes, many erupting constantly. Juno has captured plumes blasting material straight into space, lava glowing, surfaces stained black by ash and sulfur. It looks like fireworks, except it's the light of molten rock. So why is a small moon this violent? Because Io orbits dangerously close to Jupiter. Every orbit, it gets stretched and released over and over, like kneading dough, until the heat builds from the inside. That constant tidal flexing generates heat, melts rock, and feeds the volcanoes. A furnace that doesn't need sunlight, only gravity. But here's the twist. Io isn't just a victim. Io is fuel. Every eruption throws sulfur, sodium, and plasma into space. That material doesn't simply vanish. It forms a ring around Jupiter, a plasma torus, and that ring feeds into Jupiter's magnetosphere, energizing radiation belts and powering auroras. In other words, Jupiter doesn't run alone. It runs like a violent ecosystem, planet and moon locked in an exchange of energy. Jupiter tears Io apart, and Io in return keeps fueling Jupiter's machine. So now the question flips. If Jupiter has an enormous magnetic field and it's being fed by Io, where is Jupiter's true generator? What is it running on? To answer that, we have to dive beneath the clouds. Jupiter has been called a gas giant for too long. But imagine this. What you see is only a thin mist over an ocean. Go deeper. Pressure rises, temperature rises. Hydrogen, the lightest element in the universe, is compressed until it is no longer a gas. At sufficient depth, hydrogen becomes liquid, not a water ocean, an ocean of liquid hydrogen so vast that Earth would be a speck by comparison. And this ocean isn't still. It convects, it churns. It drags heat upward and pulls material downward. Those motions are the pipeline that feeds energy into the upper atmosphere, powering storms, jet streams, and the chaos we observe. But Jupiter does something even more mind-bending, deeper down. Under crushing pressure, electrons break free from atoms. Hydrogen transforms into metallic liquid hydrogen, a conductive fluid like molten metal. And this is the key to the entire story. A gigantic, electrically conducting ocean spinning rapidly is a planetary dynamo. That's why Jupiter has such a powerful magnetic field, blazing auroras and deadly radiation zones. Jupiter doesn't just have storms, it has an engine. And that engine may be interacting with everything. The atmosphere, the jet streams, the moons, and the space around it. But then Juno measured gravity and magnetism and revealed something even harder to digest. Jupiter's core may not be a clean, solid ball the way we learned. Instead, it may be diffuse, a fuzzy, mixed core where rock, metal, and metallic hydrogen blend into one cosmic slurry. No sharp boundary, no solid ground, just matter crushed into behaviors unlike anything we experience on Earth. And that points to two unsettling possibilities. One, Jupiter formed in a way we still don't fully understand. Two, early in its history, Jupiter may have suffered a massive impact, violent enough to stir the core and leave it permanently scrambled. And that's exactly why the Jupiter system will become a major focus in the decade ahead. ESA's JUICE mission is heading toward Jupiter's icy moons, Europa, Callisto, and Ganymede, searching for subsurface oceans, magnetic signatures, and chemistry. NASA's Europa Clipper will repeatedly fly past Europa, scanning the ice, hunting for signs of active water. Because if there is any place in the solar system that feels like a waiting room for life, Europa is one of the strongest candidates. But when it comes to Jupiter itself, the biggest conclusion remains: it is not a ball of gas. It is a layered system. Deep storms, a liquid hydrogen ocean, a metallic hydrogen ocean, a colossal magnetic field, and Moon Air S injecting energy into it every single day. Jupiter is not one planet. It is a machine. So what do you want next? Could Europa really host life? Or how did Jupiter shape the entire architecture of the solar system? Drop a comment. Whichever topic gets the most votes, I'll make the next episode. And don't forget to like and subscribe so you don't miss what comes next. Thanks for watching all the way to the end. Wishing you peace and happiness.